following back-to-back stem and leaf plot represents the number of icy poles sold at a swimming pool for 2 different months. Determine the interquartile range for April. So in April we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 pieces of data. So 20 add 1 divided by 2 is 10.5. The median is between the 10th and 11th pieces of data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's just there. So we have 10 pieces of data in each list. 10 plus 1 divided by 2 is 5.5. We need to be between the 5th and 6th pieces of data. 1, 2, 3, 4, 5. So in this gap here. And 1, 2, 3, 4, 5. So that's in this gap here. So the upper quartile is 21.5 and the lower quartile is 7.5. So 21.5 take away 7.5 gives us 14. Show mathematically whether the data 59 in April is an outlier. So that's going to be the upper quartile add 1.5 times the interquartile range. So the upper quartile we said was 21.5, add 1.5 times 14, so 21.5 add 1.5 times 14 gives us 42.5. So 59 is greater than 42.5 and that means it's an outlier. We now want to describe how the two datasets differ in terms of their shapes. Well, if we look at April, most of the data is at the bottom end and then there's just the outlier over here. Whereas here most of the data is at the top end and then it goes this way. So that means that January, with many large values, is negatively skewed, whereas April, with most of its values at the low end, is positively skewed. State the measure of center and measure of spread that best represents the data. Well, when it's skewed, we're best off to use the median for the center and the interquartile range for the spread.